A steel bath with a temperature of 1500 degrees. Sparks fly as a diesel engine is about to be born, a veritable colossus. The huge engine will soon power a modern ship. It will have to withstand enormous pressure and extremely high temperatures for many years. Manufacturing such a giant calls for high tech and precision. One of the most powerful high-speed diesel engines in the world, it is part of the MTU concern's Series 8000. Made in Germany, the engines are produced in Friedrichshafen on Lake Constance. Malta. From here, the high-speed ferry Jean de la Valette transports passengers as well as cars and other goods to and from Italy. The catamaran ferry is the most modern of its kind in the Mediterranean, and it is powered by 4 Series 8000 engines from MTU.
Okay, starting.
3 levels below deck, the crews start up the ferry's 4 mega diesel engines. At idling speed, the men check that everything is technically in order. This takes 10 minutes and is a must before every voyage. The team then head back up, because down here things are about to get very loud and, above all, extremely hot. The Jean de la Valette leaves Malta bound for the Italian island of Sicily, 120 kilometers away. Weather permitting, the 52,000 horsepower ferry takes less than 2 hours for the crossing. On the open sea, the 1,500-ton catamaran can reach a speed of up to 42 knots. That's 75 kilometers an hour. This extreme performance is achieved through its 4 MTU Series 8000 diesel engines. MTU Series 8000 consists of 20-cylinder common rail diesel engines. Each unit is 7 meters long, 2 meters wide, and 3.5 meters high. Roughly the same size as a steam locomotive, it also weighs as much, around 48 tons. The 20 cylinders have a capacity of 350 liters and produce 13,600 horsepower. Fuel consumption is 2,000 liters an hour. The core element of the engine, and its biggest component, is the huge crankcase. Like all the engine's components, the crankcase also comes from Germany. This foundry in Frohnberg in Bavaria is the birthplace of the mega diesel engine and a location with a long tradition. A small smithy existed here way back in the 15th century, so hot iron has been molded in Frohnberg for nearly 600 years. Today, the foundry's 3 smelting furnaces are operating at full speed to cast a Series 8000 crankcase. For 10 hours now, the steelworkers have been feeding the voracious furnaces different materials.
The materials we need for the Series 8000 are steel scrap, pig iron, and deep-drawn sheet metal. We also need electrode graphite and silicon carbide. The composition is calculated by our superiors, in this case by the engineers in our production planning department.
Casting a crankcase calls for 16 tons of material. Hot, hard work for the smelters who have to keep a constant eye on the temperature. Only when the molten metal has reached a temperature of 1,500 degrees is it ready to be transported to the mold.
Here we have a measuring sleeve made of pressboard. Inserted at the front here is a thermal element. It's attached to a measuring probe and used to measure the temperature of the melt.
Every steelworks has its own recipe. Time and again, the smelters add this or that material. The better the composition of the smelt, the harder and more durable the crankcase will be. From time to time, the smelt is checked. In a modern foundry, a sample of the molten metal is poured into a crucible containing a small measuring sleeve which, in a matter of seconds, transmits the temperature profile to a computer in the office. The smelt has the perfect composition when the sample cools down in a certain way and then heats up again. The enormous heat is no longer generated with fire, but with electricity. The principle is similar to the way an induction cooker functions in a domestic kitchen. The big difference is that the 3 electric induction furnaces in the foundry have the power of 5,000 microwave ovens. Their 4 megawatt have heated the molten metal to a temperature of over 1,500 degrees. 200 meters away, the mold is already waiting. Speed is now essential. The steelworkers transfer the molten mass. The final ingredient, magnesium, is added via chutes.
The bubbling sound you can hear stems partly from the magnesium. At temperatures of over 1,500 degrees, magnesium vaporizes much faster, and that's what causes the bubbling sound.
The magnesium vapor flows through the molten metal like carbon dioxide through mineral water. This changes the molecular lattice structure of the steel and will make the crankcase slightly elastic. The 19 tons of molten mass now flow into 2 huge casting ladles. There would be no point in having more than 2 because the crankcase mold has only 2 intake funnels. This is what the various parts of a crankcase mold look like. These 2 disc cores consist of resin-soaked quartz sand, which, after setting, has become rock hard. 10 of these cores in sequence comprise the mold of a Series 8000 crankcase. Prior to casting, each template is given a coating which has a horrific smell to it. The coating prevents the sand from mixing with the steel during casting.
The molten steel flows into the mold via this channel. It passes through the filter chamber with its ceramic filter and enters the mold cavity via this feed channel and then spreads throughout the entire mold.
But before that, the 10 disc cores are placed in a casting box. The cavities are filled with special sand. Without this sand, parts of the mold would fly off during casting. It's a job which calls for a lot of experience. Any mistake could render the mold useless. All this takes place days before the actual casting, which also demands total precision. The clock is ticking. The molten mass is cooling by the minute, so the smelters have to check its temperature time and again. On no account must it drop below 1,400 degrees. Then the mass would no longer be suitable for casting. A huge overhead gantry transports the cauldrons to the mold. The big moment is close, the birth of a mega diesel engine. The 2 casting ladles are positioned over the 2 filling funnels. From now on, everything will have to take place with absolute synchronicity. The head smelter starts the countdown.
3, 2, 1, go!
In a fascinating spectacle, the molten metal flows into the 2 funnels. For the moment, the two plugs are still in place because the mass first has to settle. Once again, the command to remove the two plugs is given by the head smelter.
Now pull!
The mass can now flow in. It takes 70 seconds for the 16 tons of molten metal to flood the mold and fill every cavity completely. The head smelter closely monitors the entire process, giving instructions to his colleagues controlling the casting ladles.
A little bit faster. Faster.
Although speed is of the essence, all movements have to take place simultaneously, otherwise swirls could form in the funnels. After a good minute, the job is done. Within a few hours, the metal cast in the mold will cool by several hundred degrees. But it will be 2 weeks before the men can peel the crankcase from its mold. Only then will it be hard and elastic enough, and extremely durable. The Jean de la Valette is surging through the Mediterranean at a rate of over 40 knots. The high-speed ferry is heading for the Sicilian port of Pozzallo. It's not a propeller that the 4 megadiesel engines in its hull are driving, but water jet power units, which function on the recoil principle. Water is sucked in under the ship and then expelled again with tremendous force.
The engine on this vessel pumps out 9.1 megawatts of power at 1150 RPM. The aggregate power is 36.4 megawatts. So in actual fact, losing an engine will not affect the vessel drastically.
The immense power from the diesel engines is a big help, especially in berthing the 1,500-ton ferry. The ship is highly maneuverable and can be steered easily, even in a confined space. The captain slowly brings the 107-meter-long Jean de la Valette against the quay wall in Sicily. In just 8 hours' time, the catamaran will be heading back to Malta. That's not a long time, because today a team of mechanics, specialists in marine engines, has come on board. One of the 4 megadiesel engines needs 2 new cylinders, and the old ones require maintenance. The men have to dismantle the diesel engine and replace the cylinders. Since a stay in port is very expensive, the specialists need to get to work straight away. This means heading down 2 levels. Awaiting the men at a temperature of 50 degrees in the engine room are a booming auxiliary power unit and the 48-ton diesel engine. They all know that this means a lot of work under time pressure. Brakes are out of the question. Back at the foundry in Frohnberg, 2 weeks have now passed. That is how long the steel block has taken to cool down completely. The heavy and, insofar as steel permits, elastic crankcase for the mega diesel engine is about to see daylight for the first time. With the help of the overhead gantry, the 16-ton Colossus is lifted out of the casting pit. This causes the quartz sand cocoon to crumble, exposing the brand new Series 8000 crankcase.
What we now see here is the down sprue and the path taken by the steel into the mold.
The first task now falls to a welder who has to sever the 2 down sprues. The gas jet slowly cuts its way through the tubes, which are as thick as tank armor. Other superfluous parts are also still attached to the 7-meter-long cast body. They were needed for the casting process. Now they too are cut off.
There's another 4, 2 higher up and 2 lower down. Then we'll tear everything down and it will remain standing in the middle.
The experienced welder burns his way along the crankcase bit by bit. After an hour, the block is fully exposed. The casting channel can be removed. But the material that has been cut off is by no means scrap. It will be needed for the next melt. The overhead gantry then comes into action again. It lifts the block to the next station, a huge mechanical vibrator. The deafeningly loud vibrations cause any remaining quartz sand to fall off. It too will be recycled. After being cleaned, the sand will be used to produce the next casting. 3 minutes later, the mega diesel crankcase is roughly clean. Its next stop is the shot blasting chamber, where the crankcase will be bombarded with a storm of tiny steel pellets.
These are the steel pellets. They're made of ordinary steel and have a maximum diameter of 2.5 millimeters. So we can roughly estimate what the surface will look like afterwards and how clean it will be.
Millions of the steel pellets are fired through the chamber at a speed of 200 kilometers an hour. This not only cleans the surface of the component, the bombardment makes the steel harder and more corrosion resistant. The process takes an hour. Then the doors are opened, and with the help of a crane, the men remove a perfectly cleaned engine block from the shot blasting chamber. The razor-sharp casting noses also have to be cut off. The crankcase can then leave its birthplace for transportation to Lake Constance. Assembly of the mega engines takes place at the MTU plant in Friedrichshafen. The firm specializes in large, high-speed diesel engines. Ships, submarines, military vehicles, and locomotives worldwide are powered by MTU systems. A Series 8000 naval engine has to pass through 6 assembly stations. 25 of these mega diesel engines leave the plant every year. Prior to assembly, the raw part is milled. The Colossus is machined to the right dimensions in several stages, losing up to a ton of material in the process. This takes several days. Engines of this size are machined with extreme precision. The tolerances to be adhered to are so minute that they can no longer be perceived with the naked eye.
We're talking about an accuracy of 3 or 400th of a millimeter. Such dimensions pose quite a challenge.
In other words, a component the size of a small bus must not deviate from the ideal by 1/100th of the width of a human hair. To check this, the Colossus is placed on Europe's biggest measuring table. Engineers measure every opening, every drilled hole, indeed every square millimeter to ensure that no disaster can occur when the engine is in operation. After 2 weeks, the crankcase is ready. Now main assembly can get underway. Over the next 5 weeks, these 35 fitters will turn the bare crankcase into an extra large mega diesel engine. The overhead gantry transports the 10-ton part to the rotary station where it is positioned with millimeter accuracy. During this process, the entire area is sealed off.
Little towards you now. Got it. It's in.
First of all, the crankcase is given a serial number. In the past, this had to be hammered in with effort. Now a special tool performs the task mechanically in seconds. The green light for assembly is about to be given by foreman Roland Bucher. He is in charge of the workshop. But first, the fitters check the surfaces and the bearings once again.
We'll illuminate the entire crankcase starting with the inlets and then continue with the main oil channels.
The two fitters' job is to detect any contamination. Tiny burrs or metal splinters in one of the channels could cause serious problems later.
The main oil channel here has to remain free of dirt, dust and splinters, which could of course destroy the engine.
Then it is the turn of the camshaft components. When it is fully assembled, the shaft will be 6 meters long and weigh 400 kilograms. To ensure that everything fits together, the mechanics work with liquid nitrogen. They sink dozens of small guide pins in a nitrogen bath with a temperature of minus 198 degrees Celsius. The liquid gas chills the metal pins and makes them contract. The super cold guide pins can be tapped into the flange of the camshaft segment with ease. As they heat up, they expand to give a really firm fit. Guide connections have to be greased and running surfaces oiled. The men then push the camshaft into the 6-meter-long channel, section by section, making sure nothing gets tilted.
That's fine. A bit lower. Then you'll see it coming. Down a bit more.
The initial phase is completed. The guide neck is now in the channel. The men slowly push it in further. Once again, this is precision work. There is zero room for error. Should something tilt, the engine would be blocked.
Up again, up some more. Just hold it like that.
When the 3 segments have been bolted together, the 2 fitters carefully push the unwieldy component through the engine. The camshaft is made of surface-hardened steel and will not be replaced throughout the entire life of the engine. After 2 days, the work at Station 1 is completed. One of the 25 megadiesel engines manufactured here each year is transported to the next station by overhead gantry. The rotary station is even bigger than the first station. Here, fitters will turn and wheel the Colossus several times and even turn it upside down. The crankcase is the biggest component of the megadiesel engine. Now the second biggest is added, the gigantic crankshaft. 6 meters long and weighing 6,000 kilograms, it is the crucial element at the heart of the engine. Operating at full speed, the heavy crankshaft will rotate at a staggering 20 revolutions per second. For installation of the crankshaft, the engine has to be turned upside down. The fitters wheel the cage. Suspended from the overhead gantry, the huge shaft now moves towards the crankcase. Once again, every millimeter counts. Very slowly, 6 tons of high-grade metal are approaching the interior of the engine. If the component were to slew, irreparable damage would be caused. After 20 minutes, the difficult task is completed. The fitters now turn the huge frame a few more degrees to gain better access to the engine's inlets. Over the next few hours, they will install 20 of these cylinder pistons. Later, the entire combustion process will take place in the power units, as they are known. Each power unit has a capacity of 17.5 liters and is basically an independent single-cylinder engine. The workshop also contains the pre-assembly site for the power units. Before assembly of the cylinders can get underway, the huge connecting rods have to be measured.
This includes measuring the bearing shells, because if the bearing shells are too small, this could damage the crankshaft. All the measurements are recorded exactly to ensure precise positioning.
Then the work can begin. The fitters first prepare the pistons, each of which has a diameter of 27 centimeters. Weighing 100 kilograms, each conrod can only be moved with a crane. The conrod is carefully lowered into the piston. The retaining bolt is then slid into place. It takes a quarter of an hour to install the first of 20 pistons. Next, the focus is on the complex cylinder head. On the rotary table, the fitter inserts 4 bolts and secures the cylinder liner with another 24 bolts. To guarantee precision, they are tightened automatically by a machine.
The process is fully automated and monitored to ensure that I haven't forgotten a bolt and that every bolt has the right torque.
The computer determines the next operation and records every action by the fitter. Now the piston, together with the conrod, is introduced carefully and slowly into the cylinder. A single error would cause considerable damage. Later, 20 of these power units will make the 6-ton crankshaft rotate at a speed of 1,150 revolutions a minute. A final component and assembly will be complete.
This is part of the exhaust.
The power unit weighs 750 kilograms. In future, it will have to withstand a great deal.
The ignition phase forces the piston downwards, turning vertical motion into the circular motion of the crankshaft.
The crankcase is turned once more, and again the overhead gantry comes into action as it brings up the power unit. The men slowly lower the cylinder unit into the engine. In its interior, the connecting rod grips the crankshaft with millimeter accuracy. The team installed 20 power units in one day. The conrods are provisionally secured with white dummies because the engine will be turned once again and nothing must be allowed to shift its position. The fitters reposition the engine block in order to install the 20 bearing shells in its underside. Each shell weighs 25 kilograms and is pushed onto the bolts of a conrod. Later, it is this area that will have to withstand the greatest forces. The up and down motion of the piston causes the crankshaft to rotate 20 times a second. The forces involved are extreme, and all the components will have to withstand them for many years. A special procedure is followed to secure the conrod. The men equip the bolt with a hydraulic clamping cylinder. They then attach oil pressure lines. The hydraulic system forces the bolt apart at a pressure of 1600 bar. Now the nut can be screwed on and the pressure reduced again. The threads of bolt and nut are pulled together in a solid link. Installation of the power units is now finished, along with the preliminary work on the fuel lines and the exhaust and cooling systems. The gantry transports the engine block on to Station 3, where a 2-man team focus on the gear train. Here it is about to be sealed with a cover, but beforehand, the men coat the edges with a special sealing compound. Weighing 200 kilograms, the cover is now attached. It is secured with dozens of bolts. In the years ahead, the gear train will not be opened again. Depending on its application, the mega diesel engine will have a service life of up to 35 years. Only then will maintenance be required. Back to the Mediterranean and Pozzallo Harbor on Sicily, where the high-speed ferry Jean de la Valette is berthed. 3 levels below deck, a team is working against the clock. The men have 8 hours in which to replace 2 power units from one of the 4 diesel engines. the maintenance work can only be carried out by specialists. While the covering is being removed at the top, one of the men crawls under the still warm engine to drain the cooling liquid. He then opens the heavy covers to gain access to the interior of the engine. Above him, two mechanics are loosening the bolts on the cylinder unit. So far, everything is going according to plan. A crucial moment. The power unit has to be taken out. The fitter has to open the eye of the connecting rod, which encloses the crankshaft. The nuts can only be loosened with a hydraulic bolt tensioning cylinder. Now pressure of up to 1600 bar is applied through hoses to ensure that all the bolts are loosened. The four main bolts on the upper side of the power unit are also loosened with the help of the hydraulic system. Finally, the power unit is free. Using nothing more than a pulley and their own strength, the men maneuver the power unit out of the crankcase. Centimeter by centimeter, 750 kilograms make their way upwards. Working at a temperature of 50 degrees Celsius, the men now haul the unit through the engine room until it is under the service hatch where the hook from the small truck-mounted crane on deck is already waiting. After 3 hours, the first power unit is taken aloft. Care is still vital because the component is by no means scrap. It will be given a complete overhaul and at some time or other be installed in another Series 8000 mega diesel engine. Today, the part is first placed in a special transport frame. But why did it actually need to be replaced? It is suspected that because of minute cracks in the cylinder head, cooling water was able to get into the combustion chamber. But only examination under a microscope will provide exact information. In Friedrichshafen on Lake Constance, MTU technicians have made good progress. The mega diesel engine is now being fitted with a turbocharger group. A complex component, the supercharger group gives the engine its impressive height of 3.50 meters. Comprised of several thousand separate parts, the turbochargers are responsible for a huge increase in the performance of the marine diesel engine. Every year, fitter Tobias Reiter assembles 25 such turbochargers for Series 8000 engines.
The purpose of the turbocharger is to increase the oxygen content of the combustion chamber. This is the intake for the exhaust gases. Here we have the blade wheel, which can rotate. Here exhaust gases flow out again, and on this side drive the blade wheel. This is where the air is then drawn in. Here it is compressed, and here it enters the intercooler. 40,000 revs per minute and a boost pressure of 4.5 bar, compared with 2.5 to 3 bar for a car tire.
Reiter needs about a week to assemble the 2-ton turbocharger. Today he's sealing the housing airtight to prevent any toxic exhaust fumes getting into the machine room later. The turbocharger group is then transported by overhead gantry to Station 5. Now the turbocharger can be attached to the engine block. 2 men connect the part with the exhaust circuit. The Series 8000 mega diesel engine now weighs around 40 tons. The clutch is then flange mounted. The fitters maneuver the huge part to the end of the crankshaft. And once again, they need special tools.
This is the cylinder with which the clutch flange will later be pushed to the back.
Here too, the components have to expand. Hoses ensure a high oil pressure of 1500 bar. The flange expands, and little by little, the clutch moves on to the shaft. 2 minutes later, the men release the pressure again. The connection is solid. The second part of the clutch is now bolted on. Above all, the giant torque damper is designed to prevent the clutch breaking off when the mega diesel engine enters operation. Once again in Friedrichshafen, it's a case of ready for takeoff. Then the overhead gantry transports the massive engine through the workshop. It will now be lowered onto the mega diesel engine's oil pan. The 40-ton Colossus is placed securely on 6 stilts.
The oil pan is filled with 2/3 of maximum capacity. That's 1,600 litres, which is the volume pumped through the engine twice every minute.
With total precision, a hydraulic hoist raises the sump to be bolted on.
2 more in the middle should be fine.
At the Friedrichshafen engine plant, all the tasks for the day have been completed. But on Sicily, there is still a lot to be done. The high-speed ferry Jean de la Valette is still berthed at the quayside. The maintenance team on board the catamaran have got a tough job in their hands. 2 power units need to be replaced, and the men now have only 6 hours to install them. The replacement unit, which has been given a complete overhaul, is lowered into the machine room through the service hatch. The 7-man team are all specialists who have been specifically trained for this engine series. Slowly, they lower the 750-kilogram part in the crankcase. Tough manual work with the help of a pulley. In the confines of the machine room, there is no space for an automatic ceiling crane. The conrod cover then makes its descent. Since it weighs only 25 kilograms, it is no problem for the mechanics. Skillful hands easily slip the cover onto the threaded bolts. 2 nuts, and the job is done. The team don't talk much. Each man knows what he has to do. Only in this way will they be able to meet their deadline. The next step is to get the injector ready. It has to be cleaned, greased, and have new seals fitted. On the cylinder head, the tolerance of the rocker arms and the valves also has to be reset. Each feeler gauge has a specific thickness, enabling the mechanic to adjust the valve clearance exactly. The cover is put on, and the men have reached the halfway stage. The first of the 2 power units has been replaced. The team still have 4 hours for the repeat procedure, removing the cylinder unit, lifting it on deck with the crane, and packing it safely for transport. The new power unit is then lowered into the machine room, installed, bolted, greased, and adjusted. All the men can do now is hope that the engine will spring to life immediately. The fitters are still working, but the ship's crew are already closing the maintenance hatch. The first trucks will soon be driven on board. Everything is still going to plan, but will the overhauled engines start up? At MTU on Lake Constance, the new engine block is again being transported by crane through the workshop. In the meantime, the mega diesel engine has become even heavier. Just before its final assembly station, it now weighs nearly 48 tons. At Station 6, the fitters focus on the electronic system and on pumps and lines of all kinds. The Series 8000 marine diesel engine is a complex structure of circulation lines for fuel, oil, air, and exhaust fumes. Several hundred meters of copper pipes, tubes, cables, and hoses have been installed in and on the engine. 2,000 liters of diesel fuel per hour, and hundreds of cubic meters of air and exhaust gases, along with 3,000 liters of oil every minute, will flow through the engine. All the lines are special, home and custom-made products, like the pipe for the seawater cooling system. The fitter assembles the separate elements of the coiled pipe in a gauge. Anything that's slightly out is ground to size so that it fits with millimeter precision.
This side needs to fit. Now it fits.
First of all, a welder joins the various sections loosely together. They're made of a very special material.
It's a cupronickel ferrous alloy. A ship's engine is exposed to salt water, but that can't affect this pipe.
Welding curved sections while the workpiece is turning is a big challenge for any welder. The seam has to be absolutely watertight. If any seawater got into the engine, it would destroy it. The final pipe for the engine block is now ready. It has been a long road. Over the last 5 weeks, around 20,000 parts have been attached to the crankcase. The result is an extra-large marine diesel engine made in Germany. Once again, the team of 35 fitters has done a great job. But one thing is still missing: the test run. No engine leaves the plant without having been tested. There are 46 test benches here, and our mega diesel engine from Series 8000 is placed on the biggest.
We start up the engine with an air starter that operates with 40 bar. It drives a flywheel which causes the engine to start up.
Finally, the big moment comes. The mega diesel engine springs to life for the first time. At the control console, Roland Bucher and a colleague increase the speed. The engine's performance is measured with the help of a water brake attached to its transmission. The water brake has a paddle wheel which rotates in the water, creating an artificial resistance. After half an hour, it is clear that the engine has passed the test. It functions flawlessly. In the hull of the Jean de la Valette ferry, still berthed in Sicily, another diesel engine of the same type still has to pass its test. A team of fitters had just 8 hours in which to replace the heart of the engine, the 2 power units. With cars and trucks now queued up in front of the ferry's loading ramp, the engine just has to start up. Otherwise, well, that doesn't bear thinking about.
Loading!
But in fact, the engine won't start. So the fitters have to check all the lines and try again.
Loading!
Success. The engine is running again. And to the ears of the fitters, the deafening noise sounds like music. The pit stop has taken 8 hours and cost thousands of euros. But the high-speed ferry is now ready once again to make the crossing to Malta. The ship's engineer just has to give the green light. Then the team of fitters can call it a day. The diesel engine can now look forward to a long service life.
These engines run virtually forever and ever. Under typical conditions, we're talking about 72,000 operating hours. After that, the engines are taken out and checked for wear. And if everything is okay, they are reassembled and put back into service.
It's already dark when the Jean de la Valette reaches Malta. Its engine is working perfectly. After performing a final skillful turn in the narrow basin, the captain reverses the ship alongside the quay. The high-speed catamaran will again be able to cross the Mediterranean 3 times a day, taking cars and trucks, goods and tourists from Malta to Sicily and back in record time and reliably, thanks to 4 mega diesel engines in its hull. Power made in Germany. By Lake Constance, the brand new engine has passed its test with flying colors. Now the 7-meter-long Colossus is heading for the wash unit, the biggest of its kind far and wide.
Every large engine is washed here. On average, the procedure takes 5 hours. At a temperature of 70 degrees, the engine is washed with a detergent and then dried for paint spraying.
It's a really tough job. Clad in a heavy protective suit, the man with the high-pressure cleaner has to cope with heat, noise, and damp. After 5 hours, the engine is spotless. Above all, it is free from grease, essential if it is to be sprayed later with a special type of paint. The roughly 1,000 cubic meters of water that are used will be treated and recycled. Prior to paint spraying, parts of the engine are masked. The sensitive cables and pipes must be kept free of the paint, which could change their thermal and electrical properties. Finally, the engine is given its coat. This, too, is a process that takes time.
We apply 2 coats. First, a primer. Then, it's left to dry for about 4 hours. Then we apply a thick coat, which also takes about 4 hours to dry.
It's a lot of work for the 2 paint sprayers who go through 200 liters of paint. Including drying time, the mega diesel engine spends 16 hours in the cabin. Now it is ready. The Colossus took 5 weeks to manufacture and will power a vessel for several years. The Series 8000 mega diesel engine has a capacity of 350 liters and an output of 13,600 horsepower. Total cost? The lower end of a scale between 1 and 10 million euros. Well packed, the engine is ready for delivery worldwide. For up to 35 years, it will operate maintenance-free as a marine diesel engine or as an emergency generator in a nuclear power station or an industrial facility. Manufacturing an extra-large mega diesel engine calls for state-of-the-art engineering. This scrap metal marked the start. The hard work of the smelters laid the foundation for one of the world's most efficient marine engines. In future, too, the Series 8000 mega diesel engine will power ships all over the world.